All right, thank you for joining us. Let's have a try at looking at binomial probability and normal distributions. And let's go to the whiteboard. Previously, I was looking at if the probability of success is 0.6, then the probability of failure is 0.4. And we had 100. Now, the mean was 100 times 0.6, which is 60. And the standard deviation is 100 npq the square root, which is the square root of 24, which is about 4.9. We can use the fact that now we've got a up 4.9, up 4.9, up 4.9, up down 4.9. So if we want the probability of between 55.1 and 64.9, we can see that that probability will be 68%. Now, you could use a calculator for this, and that is if you go to interactive, distribution, continuous. So we go interactive, distribution, continuous, and then norm, StDev. It'll give you a lower and an upper. So if I put in the lower limit as 55.1 and I put the upper limit as 64.9, now the standard deviation was 4.9 and the mean was 60. Now you can use your calculator and then that will give you, let's just do that again, continuous, norm, the lower limit is 6, oh, I know what the calculator is doing, it's compounding, I've just got to clear my screen. Interactive, distribution, continuous, norm. Lower limit, 55.1, upper limit, 64.9. The standard deviation was 4.9, and the mean was 60. All right. It says 0.6826. So on your calculator, you get a more accurate figure. That's for paper 2. But for paper 1, they would give you values that you need to use 68%, 95%, and 99.7%. Now, if I can, I'm going to try to do a question out of exercise 16E. But keep in mind, my computer's on the blink, it shuts down. So we have to, I think my voice continues when the screen stops sharing. Now, what I'll try to do here is, if I can, let's try again. Okay, I'm going to use my calculator for a few questions now, because sometimes these type of questions lend themselves pretty good for a paper 2 style question. An exercise 16E, if you work through it with me, a dice is rolled 100 times. What's the probability of more than 10 sixes? So let's just work on this screen because I don't want to risk it. The probability of a 6 is 6. The probability of not getting a 6 is 5/6, and we're rolling a dice 100 times. So the mean is NP. So that's 100 times 1/6, which is 16.6 recurring. The standard deviation is the square root of NP, PQ. So it's the square root of 100 times. Let's just do that calculation on, if you can remember what we just wrote. So we said the mean is 100 times 1/6. This is question 1 of exercise 16E. 100 times 1/6. And we get 16.666666. All right, that's the mean. The standard deviation is the square root of 100 times 1/6 times 5/6, because it's the probability of success times the probability of failure. All right, get the square root of that. That's 3.727. Now we're going to take these values, not going to use, we want the probability of more than 10 successes, more than 10 sixes. So sixes means the lower limit is 10. So I don't think you can see my screen at the moment. So let me try this. I'll try presenting again. $3.727, which was 100 times 1/6 times 5/6, and we get 3.727. In your calculator, you've got to put these numbers in your calculator. So you go to interactive, distribution, continuous, norm, StDev, and you put in, come on, it's not doing it. Interactive, distribution, continuous, norm, StDev. Okay, the lower limit, you put, screen's gone again. The lower limit, you put 10, because we want more than 10 sixes. The upper limit, let's put infinity. We want to go right through to infinity. This is using our normal curve. Our standard deviation was 3 point, what did we say? Don't have 3 point, don't have it on, 727, 727, yeah. Interactive, distribution, continuous, norm. Lower limit 10, upper limit infinity. Standard deviation 3.727, and the mean was 16.666. Okay, we get 0.96315, and the answer in chapter 16 E is 0.9632. Yes, so to 4 decimal places, 9632. So my screen's come back on. Let me try to present that again. And if you want to type it in, you go norm, StDev, the minimum 10, the upper limit infinity, the standard deviation is 3.727, and the mean is 16.67. Put that in your calculator or use the interactive, and you will get your correct answer. All right. So that is where The mean was 16.67. And we want from 10 and above. And so that's using normal distribution. And if you see the words, the probability that if you see the words, use the normal approximation to the binomial distribution. Let's look at question 2, and then I'll finish. If 50% of the voting population on a particular state favor candidate A, what is the approximate probability for more than 156 in a sample of 300 will favor that candidate? Now, probability of success is 50%, so the probability of failure is 50%. Using our formula for mean and standard deviation, the mean is NP, and the standard deviation is the square root of NPQ. So let's try and put the answers on the whiteboard. And good. Did it go up? Doesn't give me much space. Oh, it's gone off altogether. All right, let's try and turn it on again. So while that's turning on, let's do the calculations. Mean is N times P. So N is 300. 300 times success is 0.5. So our mean is 150. All right, so let's put that here. The mean is NP, so 300 times 50%. So the mean is 150. The standard deviation is square root of NPQ, which is square root of 300 times 0.5 times 0.5. So let's do that. The square root of 300 times 0.5 times 0.5. We get an 8.66. 8.66. 8.66. We go to the calculator now, interactive, distribution, continuous, norm. The lower limit is 156, more than 156. The upper limit is infinity. The standard deviation was 8.66, and the mean was 150. Okay. We get 0.2442. 0.2442 is the probability that we will get more than 156. 0.2442, and just looking at the answer, it was 0.2442. So good luck with exercise 16E. I'm going to now cancel this, and hopefully we can record a third attempt a little bit later to answer a few more questions from exercise 16E. But we're dealing with our two formulas. The mean is NP. The standard deviation is the square root of NPQ. Then you use either your calculator, or you can use the 68, 95, and 99.7 rule. All right, good luck with 16E. Sorry for the technical issues. We have to roll with the technology that we have. Have a happy day.